Hello, welcome to this tutorial. This is mechanics of materials, and in this we are going to cover the concept of elasticity, plasticity, Hooke's law, modulus of elasticity, modulus of rigidity, factor of safety. So one by one we are going to deal with these terms. So here start with elasticity. So what is the elasticity that we are going to deal with? A material property. So these are the material property. Here we are taking the solid material. In this material, this is the material property by which a material returns back to their original shape and sizes just after removal of external loading. That is only known as elasticity. What happens? You can see through the diagram. So what is happening here? Here one solid member is taken and that is experienced due to applied load. So due to applied load, the change of the change of length in the material is occurring. So what is happening? The length is increasing due to application of the load. Suddenly we are removing the load from the materials. What will happen? Whatever stretch produced due to the application of load, that's again going to recover, and after removal of load this member will be remain whatever it is. So length will become L. Okay, so this is about elasticity. Then next concept, what is plasticity? What happens in plasticity? So in plasticity what happens? There is a permanent set, there is a permanent deformation. So as we define this term here, plasticity is a material property in which materials deforms due to the application of load on it. So while applying load on the materials, it's going to deform. Then what will happen? But as load removes, material does not recover its deformed shape. Means it's going to set permanently. It's not going to recover its shape after removal of loading. So what happens? This phenomena is called as plasticity. So you can see here, with application of load it is deformed. After removal of load is not going to recover. Means this phenomena is called plasticity. So here we have seen about elasticity and plasticity. So this is the concept of elasticity and plasticity. In elasticity, that after removal of load, material shape and sizes will recover, but in plasticity, even after removal of loads, whatever deformation happened, that deformation not going to recover. So that there will be permanent deformation in the material. So in this regard we will see about Hooke's law. So what is Hooke's law and how it is applicable? According to Hooke's law, it is stated that when a material is loaded within elastic limit, so we'll see in later session that what is elastic limit or what is proportionality limit. So that we'll see. But here just term is elastic limit. It means a limit from which if a load from the material is removed, that material will regain its original shape. So that is the limit. From that, after removal of load, material will regain its shape. Whatever distortion happened, whatever the changes happens, that will recover. So here according to Hooke's law, it is stated that when a material is loaded within elastic limit, the stress is proportional to strain. So as stress is proportional to strain, what happens? That stress due to the application of loading, stress produced, and due to that there is a deformation. Means what will happen? Here the changes will happen in the solid members. So as we defined, here stress will be load per unit area and strain will be that change in length, suppose delta by original length. So generally we deals with, so this both the parameters will be proportional to each other. It means if stress is increasing, strain will increase. Means there is a linear relationship between stress and strain. So while we are removing the proportionality, what will happen? One term will come E, and that is named as modulus of elasticity. So this is constant term. If you are taking a material, a particular material, for that particular material E will be constant. Means if you are taking a material and you are considering a number of points in that materials, then E not going to vary. E will be constant because for one material E will be 1 only. So it's not going to change. So next, this constant term is known as modulus of elasticity, or in another name we can say Young's modulus. So that is clear. Now here some more terms are there, that modulus of elasticity or Young's modulus. So how it's going to define? So as we see here, the ratio of tensile stress or compressive stress to the corresponding strains. So whatever stress is produced, whether it is tensile or compressive, in because of that strain will be produced. Means there is a variation in the material size and shapes. So how it will define Young modulus, that is E will be defined tensile stress by tensile strain, because it is ratio of stress to strain. So here we are talking about tensile and compressive. So while considering tensile force, so due to tensile force, tensile stress will produce, and because of stress, strain will produce. So here tensile stress by tensile strain. Accordingly, for compressive load, here it will be defined the ratio of compressive stress to the compressive strain. So this is the definition how we will define the modulus of elasticity. So by seeing the Hooke's law only, easily we can identify and we can define the modulus of elasticity or Young's modulus. So that we can write E is equal to sigma by E. Sigma is a stress, E is a modulus of, here E is equal to not sigma by E is equal to stress by strain. So let us make it strain. So this is defined. So next, see the modulus of rigidity or shear modulus. So this is the material characteristics against shearing from a section. So here how it defines the ratio of shear stress to the corresponding shear strain. So here also we are going to take a ratio of shear stress to shear strain, and its symbols is G. So that different people takes different symbols also, and it is given in various textbook, but here I have been considered symbol G. So here G is equal to shear stress by shear strain, as shear stress is defined by tau and shear strain that is defined by phi. Okay, then after this we'll see one small term that is called factor of safety. So what is the factor of safety? It is defined as the ratio of tensile stress to the working stress or permissible stress. So this is the ratio, tensile stress and working stress. So factor of safety that can be written as FOS is equal to tensile stress by working stress. So this is about this session, as here it is taken as a topics in mechanics of materials. That topic is elasticity, plasticity, Hooke's law, modulus of elasticity, modulus of rigidity, and factor of safety. So thank you for watching this video, and I'll request, please try to subscribe and share these videos. Thank you.